Hi everyone, this is our position paper towards meaningful grounded conversations with intelligent agents, where we explore some of the limitations of current works and propose a way to overcome them. I'm sure you're all familiar with the proliferation of conversational agents around us, such as Siri, Alexa, Google Assistant, and many others, embodied or not, virtual or physical. For our purposes, we will not distinguish between virtual or physical agents, but we will categorize them as transactional and non-transactional agents. Our proposed model aims to shift away from the rigid slot-filling dialogues to a more realistic and flexible paradigm, and to handle concrete and abstract entities as well as the evolving relations between them. Recent work on the field has mostly focused around machine learning approaches to conversation modeling, and in particular reinforcement and deep learning. While the concept is not new, lately there has been a trend to incorporate knowledge bases or knowledge graphs to better ground the conversation. In the paper, we discussed some representative works, but could not cover everything due to space constraints. It is undeniable that such methods have helped push the field forward over the last few decades. Despite this progress, however, there are still many limitations in current works. Most recent works model the dialogue as a slot filling problem or take a similarly simple approach. There is no distinction between soft and hard constraints, and while some works do handle dynamic knowledge graphs and unseen entities, no works can handle unseen relations, at least to our knowledge. Likewise, there is little distinction between the various types of entities, for example, objects which may be physical or conceptual, and the relations between them that may be dynamic. Many systems, particularly end-to-end trained systems, exhibit a lack of in-depth knowledge that users are quick to realize. A simple and repetitive language is also a general concern. Last, no system can really handle interactions over longer periods of time, primarily due to the lack of longitudinal data, where users talk to their assistant over, let's say, a year or two. Hopefully, this is about to change as we spend more and more time with our personal assistants. Aiming to address some of these challenges, we propose a middle ground approach between traditional pipeline systems and fully end-to-end trained systems by combining two existing methodologies: information navigation and conversational entity dialogue models. Information navigation goes beyond slot filling by not assuming that users more or less know what they want, and instead helping users discover interesting things about the world. Hard and soft constraints and multiple operators that may be clearly defined or fuzzy, like around or between, allow us to cluster and order the items, and thus allowing the system to do more interesting comparisons, suggestions, and other things. To facilitate information navigation, we chose the conversational entity dialogue model, an entity-centered model where, as you can see in the table, entities can be permanent or transitory and generally exist within the scope of the conversation. An entity may be an object or a relation, and CEDM will keep track of them, allowing the system to engage in more complex interactions and, of course, facilitate information navigation application. This is a generic architecture of the proposed model, where the encoder and decoder parts can be any type of model, and CEDM will keep track of the dialog state, objects and relations between them, relieving the decoder of this load, and relieving the need for processing the input every time at every dialog turn. By explicitly tracking entities and relations, CEDM for IN can address the limitations mentioned above, as it is designed to handle complex dialog structures that in turn allow it to facilitate complex interactions that are grounded in short and long-term history, thus exhibiting in-depth knowledge and avoiding repetitive language. In this work, we have presented CEDM for IN, a new methodology for modeling conversational agents that stands in between traditional pipelines and end-to-end systems, can track objects and evolving relations between them, and can guarantee system behavior, and of course it's more easily interpretable than end-to-end architectures. As future work, we plan to prove our approach on well-known benchmark domains. Thank you for your attention.